All right, so can everybody hear me okay? Look good? Okay, terrific. So again, my name is Dave Boucher. I've been with SaltStack since before there was even a company, when Tom Hatch was writing Salt in his basement, trying to solve some problems he had in his job at the time. And I've been working with Salt, building and advising people building out huge infrastructures and some of the biggest infrastructures in the world. I've trained SREs at LinkedIn, engineers at JP Morgan Chase, and a lot of different places. And one of the things I love about Salt, and why I got so excited about it in the beginning, is I recognized really early on that Salt is more than just configuration management. Salt gives you a whole bunch of tools to build out your infrastructures how you need. Every infrastructure has politics involved, inertia, history, money. And so a tool that can allow you to build what you need and do so in a way that is very, very flexible is in my opinion, very, very powerful. And so today, I'm going to do a little bit of kind of like intro to Salt, just make sure there's kind of a high-level understanding of how Salt works. But I'm going to assume that you already have some understanding of configuration management and hopefully a little bit of Salt usage as well. And I'm going to jump into some deeper parts of Salt that allow you to build out interesting things. And I have a live demo of something that's ridiculous, but will kind of show some things you can do with Salt. So who here has installed Salt and used it at all? Okay, a few. And in production? Oh, you have? Okay, about the same number. Okay. So so basically there's kind of a few things that are important for Salt that are the kind of the basics you have to know. One, Salt minion is the agent that you run on your server that allows it to be configured. The Salt master is your centralized master control. And we also have a thing called Salt SSH that allows your Salt master to connect over SSH to your servers. The Salt minion can be run standalone, but that's kind of where the main terminology is. So you can see here, we have our Salt master at top left. We have our two Salt minions that are our servers that we're connecting to over our ZRM queue. And this is kind of like a typical layout here. The minions connect to the master over ZRM queue, and your master can send out commands, they can communicate, gives you full control over those minions. We also have a diagram here, this third minion. For some reason, we can't install the Salt minion, or maybe we don't want a constant connection to it. So we're connecting over Salt SSH. So whenever we want to run a command or configure that server, we use Salt SSH, and that'll SSH in and run all your Salt configs and everything. That's kind of a typical layout. Now you can use Salt in other architectures. So you can use the Salt minion by itself. So it can just have all of its configs local, or it can reach out to a Git server force configs to reach out to S3. Lyft.com does that. They use auto-scaling on AWS, and they use their minions without a master, and they pull all their configs from S3, I believe, and they control it that way. We also have a multi-master setup, two different types. One, you have a syndic where you can have a high-level master and then lower-level masters that report back up to the highest one. So if we went back to this diagram, we would have another green one up above that could send commands to this master down to the minions below, and those results will go all the way back up to the higher level master up above. And we can also do a multi-master mode where you have multiple masters that all have standing connections to your lower minions as well. Let me just kind of demo a few commands here. So on this server, I just have two minions connected to it. So you can see here, I run the salt command. That /* is the target. So the asterisk means we're going to target all the commands, and I'm sending a command test.ping. Ping is a Python function in a test.py module that we just executed on these two servers. One's an Ubuntu server, the other one's a Windows server. So you can see that command is cross-platform. There's other things we can do. There's a whole library of executions that you can run. So for example, we can do a disk usage command here. So on this Windows machine, the C drive, we're at 69% capacity. If you go up here to the Linux server, you can see our capacity here. You can use this. You can get this data in different formats as well. So, say I want that in JSON format, so that I can then use that in some other application. I can get that back in JSON format as well. You can do a variety of things like that. So let's real quickly let's look at this test module. Okay, so here's test.echo. You can see here's a Python function. Just echo. It takes an arbitrary text. We have documentation on exactly what this command does and an example, a CLI example, and then it just returns the text. Super simple. So a lot of times people will find that they already have Python scripts that they're using for various things, for checking values or a variety of system administration tasks. They translate into Salt modules many times without even changing anything at all. The nice thing about that is then you can also distribute those from your Salt master to all your servers and run them and execute them. As you go along, if anybody has any questions, feel free to raise your hand. If I think the answer might take a little bit too long, then I might save it till the end so we can go into more detail and not disrupt the flow. But I do like to entertain questions, so if anybody has any, they're more than welcome to ask them. This is a salt state to install Firefox. So Firefox is the package name. PKG or package.installed is a stateful representation to install Firefox. That's all it is. So Salt by default uses YAML to execute them. So if I wanted to run that, I could do salt *state.firefox, and that would install Firefox. And again, that's a cross-platform execution. So that will work on Gentoo, Ubuntu, CentOS, Windows, pretty much any OS that we support, that would work. Okay, now I'm going to talk a little bit about some of the advanced features that I'm going to demo. Again, Salt is very pluggable. Tom built Salt. Kind of has his terminology. He calls it loader programming. There's something like 15 or 16 different pluggable parts of Salt that you can use both with out-of-the-box functionality as well as add in your own. If we look here under the modules, this section here is the authentication. So these are all different things that you can authenticate against for your Salt. So you can authenticate against PAM, MySQL, database, Django, Stormpath, Yubico keys. It's just a generic REST interface. We're going to talk about beacons here in a moment. These are all the different clouds that we support out of the box. These file servers are locations you can pull data from. So you can pull things from Git, Mercurial, S3 subversion, logging modules. So you can see here, this just goes on and on and on. It's just incredibly pluggable. So a lot of our users and customers have large infrastructures that require integrating with different things. For example, at Adobe, one of their business units, they already have a CMDB where they keep details about specific servers that are important, where they have users and a variety of other things. So they very easily were able to build a pillar module that reaches out to that CMDB and gets that data and then uses it within Salt. People use, they have Active Directory for all of their authentication. Salt can use that for their authentication. A whole variety of things like that. So you're not stuck with just what's out of the box with Salt. Okay, so first thing here we have the Salt Event Bus. Again, kind of looking here at our kind of typical architecture here. Salt's Event Bus there's one that runs locally on the minion and also one that runs from the minions up to the master. The Event Bus receives data of all the things that happen on the minion. So if you run an execution module on the minion, if you, when you start and restop the Salt Minion service or the server itself, when that minion authenticates to the master, all those types of things flow across this Event Bus. That allows for this really rich communication between your minions and your master. So there's a variety of things you can do with that. Now, you can also create your own events. So within your own execution modules or just on the command line on the master or on the minion, if you have writes, you can send messages from your minions up to your master. The next item here is a beacon. A beacon is it's a very simple Python module that runs on your minion that'll run at an interval that you specify, and it will do something and then send a message up to the master. So for example, you look at the beacons we have here. We have a disk usage beacon. This disk usage beacon so say you check every minute, for example. It'll check every minute, look at the disk usage, then you can put in various thresholds, and if the disk usage falls outside those thresholds, it'll send a message up to the master. Same here with load. It'll check your load on the interval you specify and send a message to the master if the load falls outside the threshold you want. We have a Twilio beacon. I'm going to demo that one here in a minute, as well as the iNotify. So the Twilio allows us to check a text message queue in your Twilio account, and the iNotify will watch a file or a directory for changes on the file system. And we'll show how that works in a minute. So again, the beacons runs on the minion and does whatever, and they're very easy to write, and it'll send a message up to the master. Actually, it can be either locally or up to the master, and then you can do something with that. Now, so we have all this data of things that are happening on your servers, and there's two things you can do with that. Actually, several things you can do with that, but one, you can use what's called the Salt Reactor. The reactor allows you to watch that event bus, look for specific tags that you care about, and when the master sees a tag, then it'll pass it off to the process and then run an SLS file or a Salt execution based on whatever happens in that tag. A newer feature is an engine. An engine can run on the master or on the minion as well, and it allows you a more programmatic Python interface to do something with those events that are coming through. So people will use the reactor and the engine sometimes to do monitoring, notifications, various things like that. There's a lot you can do with those. It also allows for setting up self-healing auto-remediation scenarios. So if a certain problem happens, who's had to deal with some application that gets in a bad state and really the only fix is just reboot the thing or restart that service, right? You could have a message come up saying, hey, this service got stuck. Okay, then we know we need to run this little script to restart it or change something. This will allow you to do that automatically. Salt also has a REST API that runs on the Salt master as well that allows you to reach into Salt and based on the configuration or the rights that you give that user is logging in, do everything from run commands, check the status of things, anything you want. So that allows Salt to fit in really nicely with all the other infrastructure that might want to use Salt to get data, to change things, to run configurations, whatever you want to do. Okay, so we have beacons and ways to send your own messages from the minions to the masters. We have reactors and engines to do things. So now we're going to demo a couple of these things. So first, all right, so here, let's see what the event bus looks like. Okay, so this is going to listen to the event bus and just output the data structure of the event that we send. So I'm going to do a salt call event.fire. So what this is doing is salt call is a way to run a command locally on the minion. We're going to do event.fire, and then the data we're sending is a dictionary that says hello Toronto is the value, and then Dave/test1 is the tag I'm going to give to that. So I'm run that. You can see here there was a key authentication that happened. And then here's this job that I just ran. You see the argument was hello Toronto, tag was Dave test, and there's a local execution. So these events are flowing through your system. Okay, so here's the configuration for two different beacons. One is the iNotify beacon and the Twilio text message beacon. So let's look at this iNotify one. So here's the beacon that we're configuring. There's a file name /serve blah.txt that we're going to return any changes that happen to that file. And then we're going to set up iNotify on a directory. We're going to recurse that directory, and we're only going to send notifications when a file is created or when it's written and closed. So let me so I just created a new file. You can see there that this file was then sent a message that was actually the swap file for my Vim session, as well as files written there. Echoed more text into it, and you can see it was written to. So you're getting data about this. So the first demo I ever did with this, I had it watch the Etsy directory on my server, and then the scenario was some hacker got in and changed the config file somehow, and then Salt recognized that the config file changed, so they ran its state to redo the config files and set it back to the correct location, as well as logging that had happened. There's a variety of things you can do. There's a WTMP that checks that you get a notification when someone logs in. So we have a couple customers that will use that for already. Okay, they'll use that to notify them that someone logged into some production server. So they have a set of production servers that basically nobody should log into unless servers are on fire. Everything else happens through their Salt configurations. So when they find out that that's happening, they send a message to that. So those are beacons. Things happen, and it sends a message about that. Okay, we're getting a little short on time. So, all right. So the scenario I have here is we're gonna have a beacon set up that will. Oh, dang it! I was trying to. I'll have to go change my account and information on my Twilio account now. But so here we have a Twilio text message beacon. It takes a few arguments: your account SID, your token, the phone number, and the interval. So every 5 seconds, we're going to check that Twilio account and do something with that. It'll send a message up to the master when that happens. Then I have a little HTML file that has some JavaScript. The JavaScript uses Salt's API to listen to that event stream. That event stream is flowing into this web page, and when it finds a specific tag that we're looking for information for texts from this Twilio account, then it's going to display them live. Okay. So again, so what's happening here is I have a server that's checking this Twilio account. When it sees a text in there, it will send that up the event bus. This web page is listening to the event bus, and then it'll output at that. And it worked first time. So this also works for MMSs. Don't worry, if you're really privacy oriented, this will be gone soon. So send an MMS. If you're in the audience, if you'd like to send a message as well, this is a US number, but it'll receive the text messages. Just keep it G-rated, please. Oh, see someone in that there. Okay, well, it was sideways on the text there. So, so we have a lot of people that will use this stream of data to do monitoring, to send data to Nagios, to whatever system they're using. Allows them to, some people will take data from this event stream and throw it into a database for auditing purposes. So if something does get compromised, they have a somewhat offsite location where this data can go. Anyway, so the purpose of this talk is I wanted to be able to show you that with Salt, you're not stuck with just what comes out of the box. You can build solutions to solve your little unique problem, because I know everybody has different things in their data centers that you need to solve, and Salt allows you to do that very easily and very quickly. Everything we did here is stock, out-of-the-box solutions that come with Salt. So nothing here was custom. This is all right now what you can get by installing Salt. So, do we have time for questions, or are we?
We have 5 minutes.
Okay. So I have a few minutes for questions. If anybody has anything they'd like me to clarify or go over or anything. Yeah.
Can you write your own beacon modules?
Absolutely. Yeah, in fact, if we can look at the
Like a underscore beacons, as you put on something?
yeah, you can do underscore beacons. You can as well as write your own. And they're really straightforward to write. So basically, this is all imports and things. All you have to have is a beacon function that gets run every interval you give it. And here there's a lot of some logging and things like that, but basically here we're using the Twilio REST API to get a list of all the messages, some more logging, going through the messages, and then we're just going to return that data. That's 87 lines total with logging, with documentation and everything. It's really straightforward to do your own. So some people will say, we'll have like a beacon that'll check some servers that they're running, and then say they'll only want to have like 50 connections on that server. You can check. Oh, we hit 51, send a message. Then have Salt Cloud spin up another VM and add to the load balancer or something.
Yeah, so is this actually good for heavy usage in terms of, for example, I want to echo like a tail of a log file constantly to another server?
Yeah, you could totally do that.
So it's not, is it more or for more like rare events that happen?
No, this is stuff that happens all the time. This runs once a second at the shortest. You can have things a lot. You can have it happen quite a bit.
And it's efficient for that kind of usage?
Yep. Yeah, it's great for that. If you have 20,000 minions and you're logging a file on all of those and sending all the data to the master, you might want, you might make sure that master is pretty beefy to handle all that data coming to it. But yeah, people use this for logging quite a bit. There's somebody in the back that had a question? Okay. All right. Yeah.
What's the current status of your alternate bus the rate transport?
So rate's still under development and being worked on. Also, there's a tornado interface is also being worked on heavily in conjunction with LinkedIn as well. So right now, ZeroMQ is still the default for the foreseeable future, but for the really, really large infrastructures, we'll have some more options as well. All right, thanks for coming. Really appreciate having everybody here. Thank you.